So hi everyone, welcome back to Made Easy Academia. So please don't forget to like our video, share so that others too can be able to benefit from these real tutorials. So now we are still under calculus. We talk about a lot of methods. In case if you missed the previous videos, so kindly go back, try to watch them so that you'll be able to follow the next method. So we talk about how we normally differentiate. We said calculus divided into two, that we have what we call differentiations. At the same time, we have what we call integrations. So we are seeing the differentiation, and we list out the sub method that we have under differentiation. So we talk about the general method. We talk about how to make use of quotient rule, the product rule, as well the functional functions, which is called chain rule, even the first principle as well, exponential function, logarithm functions, trig functions. So now we are continuing from another method. So the one we are going to talk about today is tangent and normal. How can we determine the equation of a tangent and equation of normal to the curve? So, but there's one thing that you need to know. There's something that we need to learn first, and let me break that one down. Whenever you ask to find the gradient, if you ask to find the gradient, it's just like what we have in physics. Let's say we have a graph like this. Let's say we have, what we have here is called the y-axis, and what we have here is called the x-axis, right? Okay, fine. Let's say I plotted the graph, either a parabola or a parabola. Let's say we have something like this. Let's say we have a straight line graph. Let's say we have 1 here, we have 2, we have 3, we have 4. And let's say we have plotted the graph already. And we asked to determine the gradient. If normally do physics practicals or simultaneous equations. So after that I have to draw the right angle triangle in which I can be able to find my x1. At the same time, I can be able to find my x2. It depends on anything they use here, but here normally this is y-axis and this is x-axis. So let's say what we have here is y1. Let's say what we have here is y2. From here I can be able to determine my gradient. How will I determine the gradient? When it says slope is what we call gradient, right? Those are the two terms that you have to master on. They can call it slope or they can call it gradient. Normally if I want to do that here, I will just have this one to be changing y over changing x, meaning from the graph itself we have 2y, at the same time we have 2x, so which is y2 minus y1 over x2 minus x1. You can see if you look at the first approach, we have changing y over changing x, which is dy dx. So which means if you have to find the gradient of a curve, is nothing but you have to find dy over dx. I hope you get it right. So it depends on the approach. It might be either implicit function. We have talked about implicit function as well. Any other function. So far you have to find the gradient of that curve. It means you have to find its derivative. That is dy over ds. Let's say for example we have, let's say given that y is equal to x cubed plus 5x squared plus 4x plus 1. Then also find the gradient at x is equal to, let's say, 1. Can you see that? So they can say gradient or they can call it a slope. Please don't forget that. Either they use slope or they call it gradient. The two terms are still the same. So now, given that y is equal to x cubed plus 5x squared plus 4x plus 1, find the gradient or the must slope at x is equal to 1. So in case if you miss the previous example, when they say at x is equal to 1, meaning after we find the derivative, we should put the value of x to be 1. So if I want to do that here, that is gradient, either we call it gradient or we call it slope. Please don't forget the two terms are the same, meaning we have to find dy dx, just its derivative. So now differential of this, we have talked about how we normally do differentiations. Differential of x cubed, we have 3x squared differential of 5x squared, and we have 10x. Okay, then differential of 4x, we normally know we are going to have 4, and differential of constant is what? Yeah, is 0. So now they now said at x is equal to 1, meaning after you find its slope, you should find the value of x, you should find the value of that gradient at this point, at x is equal to 1. So therefore, at x is equal to 1, meaning in this answer, in this result, whenever I see x, I should put the value of x to be 1. So therefore, we have dy dx is equal to 3. So x is 1 now, that is 1 squared plus 10 of 1, then plus 4. You can see we have x here, we have x here, and there is no x here. So here we have dy dx is equal to 1 square. You know, 1 square simply means 1 times 1. So 3 times 1, and we have 3. Okay, though I will not jump a step. You know, 1 square is nothing but 1 times 1, and we are going to have 1. Plus 10 times 1, we are going to have 10, and that plus 4. So here we have dy dx is equal to 3 times 1 is nothing but 3 plus 10, then plus 4. So here we have 17. So which means our slope is equal to what? Or our gradient is equal to 17. So it might even be a question from under implicit functions. Let's try one. Let's solve one question from there. Let's solve a question from there, then you see how we can make use of that and put two as well. Maybe they said, given that let's say x squared plus y cubed plus 5y squared is equal to 3s plus 6. Now say find the slope or find the gradient at x is equal to minus 1. You can see if you look at this problem, which function is this? Can you recall that? Yeah, it's implicity. You know, under implicity, we know we are going to find derivative of x. At the same time, we are going to find derivative of y. So now, what we have is and remember, if you recall, in case if you missed a previous video on that implicity, please kindly watch that one so that you'll be able to recall the method that we use. You know, under implicity functions, we are going to differentiate x, and if you are differentiating x, we know it's normally carry dx ds. Remember that? Yeah. And what about when we differentiate y? What are we going to have there? We are going to have dy there. So now, from the problem, we have x squared plus y cubed 5y squared 3x plus 6. So now, if I want to go with this, so differential of x squared, you know, that one is nothing but 2x. Then if this is x, then of course I will have dx. Then differential of y cubed, you know, differential of y cubed, that one is 3y squared, and this is going to be dy dx plus differential of this one too as well, and we have 10y dy dx. You can see, recall under implicity, when we are differentiating respect to x, it's dx, and we know that one is nothing but 1. But if you are differentiating respect to y, that one is going to carry dy dx. So here, differential of 3x, that one is also 3. Then we have dx, and recall that differential of constant is going to be what? Yeah, it's going to be 0. Yeah, fine. So now the next step is to arrange those who have dy dx one side and the one without dy dx to the other side. You can see, if you look at this side, we are okay. Let's firstly remove this one because we know that the ds is nothing but what? Yeah. So then here we have 2x, that's the first one, plus the second one we have here is 3y squared dy all over dx. Then followed by this, we have 10y. Okay, let me change the nature of the problem to make it more better. Dy dx is equal to 3. So now let's say we asked to find at, let's say at minus 1 and 1, for example. So now, so after that, we can see here we have dy dx, and here too we have dy dx. So let's collect like terms so that the one with dy dx will be at one side, the one without dy dx will be at the other side. So that means here I can have 3y squared dy dx. So now here too we have dy dx, that's a plus 10y dy all over dx is equal to, you can see here, do we have any dy dx here? So bring it here, that means that we have 3. So this is plus 2x. So when it comes here, we are going to have minus 2x. So let's check from here to here. What do we have in common? Yeah, good. So we have dy dx is equal to, so what do we have left here now? Yeah, so we have 3y squared, and here, after we have already bring out dy dx, we are going to have plus 10y is equal to 3 minus 2x. So what we are trying to find is dy dx. You know, I told you earlier, we have to find the gradient is nothing but dy dx. So divide all through by 3y squared plus 10y, 3y squared plus 10y. So here, if this cancels this, that means that we have dy dx to be, so therefore dy dx is now 3 minus 2x all divided by 3y squared plus 10 plus 10y. Assuming if this point is not given, this is going to be our slope, this gradient, but we are given the point that at point of hat minus 1 and 1, meaning when x is, just like a point that we have in the gradient in the point. So when we have something like this is always x and this is always y. So here now it means our x is going to be equal to what? Minus 1, and our y is going to be equal to 1. So meaning in this result, I'll put the value of x to be minus 1 and I'll put the value of y to be 1. So therefore we have dy dx is equal to 3 minus 2. So x is minus 1, this minus 1 divided by 3. Y again is 1, and we have 1 squared plus 10, y is also 1. Just a simple substitutions after we have been given the 2 points. So therefore we have dy dx of this to be 3. Now, minus times minus. What are we going to have? Yeah, we are going to have plus divided by 1 square is also what? Yeah, good. So 3 times 1 and we have 3, then 10 times 1 we are going to have 10. So here 3 plus 2 we are going to have 5 over 13. So which means our slope here is equal to 5 over 13. Oi. Well, no. I'm really sorry. In red. So now, well, okay. Shall we better live? But I am good at all. Okay, about Boon. Hudson. Okay. So now we are not going to use this approach in finding tangent and normal. Finding tangent and normal. Tangent and normal. So tangent and normal. So let me just give a simple illustration of that. We have a point like this. So this point is normal. Why this is called tangent, but you don't need to worry about this. So in case if you need the material for this, so once you subscribe, you'll be able to get the materials or we are using, and we explain in details of how we make this of approach. So for example, let's say here is y is equal to f of x. Here, if I want to find, normally I told you under the derivative. So here, the y dx is nothing but what? Is nothing but f prime of x. Recall if I have the y dx is the same thing as f prime of x. If you have the square over the square is nothing but f prime, all those ones. So now, let's go to our main tangent. So here we only want to find, how can we find equation of a tangent? Can we refill this marker? Change done. So equation of a tangent, can you refill them? Even these two. It has seen it. Equation of a tangent as well. Equation of normal to the curve. Equation of normal to the curve. Let's see, to the curve y is equal to f of x. So we have already mentioned that if you have to find dy dx, we said dy dx is nothing but what? It's nothing but gradient. So how are we going to relate to this? Either you have to find equation of a tangent or equation normal to the curve. I'll just give you a simple formulas. If you ask to find equation of a tangent, for equation of a tangent, so just a little difference. Equation of a tangent, if you have to find this, just a formula, we normally apply this, y minus y1, but if you need the province of this, we are going to provide the materials for you. Once you subscribe, you'll be able to have an access to that material. So y minus y1 is equal to gradient, which is a dy dx of x minus x1. So meaning, if I want to find the equation of a tangent, for every point we have x and we have y, just like what we used in the previous example. Let's say we have u and v. As I told you, I said any point they put here, anything they put here is for x, and whatever they put here is for y. So now, that means in that particular problem, I will firstly find the gradient. Then after getting the gradient, I will now find the equation of a tangent. Since from there, we have my y1, and at the same time, we have my x1. So the only difference between the equation of a tangent and that of normal, equation of normal to the curve, the formula of that one is given as this: y minus y1 is equal to minus 1 over dy dx of x minus x1. Can you see the difference? What is the difference between them? You see, in the first one, what we have is just dy dx of x minus x1, but in that normal we have is y minus y1 equal to minus 1 over negative 1 over dy dx, which is our gradient, then x minus x1. So let's see one example, then we'll see how we normally apply that. So let's see one examples. Okay. Complete. Now, so in this example, they said, let's see question 1. Find the equation of the tangent and normal. Find the equation of the tangent and normal to the curve y is equal to 7x7 raised to the power of 7, 8x raised to the power of 6, plus x4 plus x3 plus x cubed, or let's say, let me change it so that it will be more better, minus x4 at 1 and minus 4. So here, that means we are looking for two things here. Firstly, we have to find equation of the tangent. At the same time, we have to find equation to the normal. But I told you, the first thing you need to do is to firstly find your dy dx. Don't forget, dy dx is nothing but what? It's nothing but slope, or they can call it gradient, or they can call it just to find its derivative. So now the first thing I will do for this particular problem, I will firstly find it what? Yeah, good. So now, so I have y is equal to 7x7 minus 8x6 plus x cubed minus 4. So I firstly find the gradient of this. That's dy dx is equal to, as usual, 7x raised to the power of 7. That one will give us 49x6. Then this we are going to have 48x5. Then differential of x cubed, we are going to have, normally we know we have already treated a lot of examples in this area. Differential of x cubed, we are going to have 3x squared, and differential of 4, we are going to have what? We are going to have a 0. So look at the point we are given. We are given the point of 1 and minus 4. From here, I can be able to point out that my x is what? Yeah, my x is 1. So why are we not using y? Because if you look at the result, not like if you look at the one we solve under implicity, after we find our dy dx, we have x and we have y. But in this case, what we only have is x. So that means at x is equal to at x is equal to 1. So if I put it here, that means that we have dy dx is equal to, now it means whenever I see x, my x is going to be equal to 1. Good. So that means that we have 49, 1 raised to the power of 6, minus 48, 1 raised to the power of 5, 3, 1 raised to the power of 2. We are just substituting the value of x to be equal to 1. So that means here we have dy dx is equal to, 1 raised to the power of 6 is nothing but 1. Even if we multiply a million times, it's still 1. So 49 times 1, and we have 49. 48 times 1, we are going to have 48. Then 3 times 1, we are going to have 3. So 49 minus 89, what are we going to have? And the 48, we are going to have 1. The 1 plus 3, what are we going to have? 4. So that means our dy dx now is going to be equal to 4. Now, since you have gotten your dy dx, you have already simplified the problem. Now, since the value of dy dx, which is gradient, has been known now, then you apply the formula to find for the equation of the tangent. You apply the formula to find for the equation to the what? To the normal. So let's see that. So if I want to find, so to the tangent now, for the first one, the tangent, equation of the tangent, from that formula, what do we have from the formula? We said, look at the formula here, we said we are going to have y minus y1 equal to dy dx of x minus x1. So we now go back to that point, the point you are given. The point you are given is 1 comma minus 4. So that means from this point, this is your x1 and these are y1. So x1 is 1. The first, I told you the first component is for x, the second component is for y. So meaning our x1 is 1 and our y1 is equal to minus 4. So I'll put in the formula. So what I have is y minus y1 equal to dy dx of x minus x1. So let's substitute the values. We have y minus, our y1 is minus 4. That is a minus 4. So why do we bracket? Because in that particular formula, we also have negative before. So here we have is equal to, so the value of our dy dx, we have it to be 4. So we have 4 x minus x1 is 1. So now let's open the bracket of this using this minus, and we have y minus times minus, we are going to have plus, so plus 4. So let's open the bracket of this, 4 times x, and we have 4x, 4 times minus 1, we are going to have minus 4. So it depends on how you want to leave your final result of this one. If you like, you can bring all this value and equal them to be 0. And if you like, you can separate them. So here I can have, if I bring this one to this side, I will have y. So this is plus 4x. So when it comes here, we are going to have minus 4x. This is plus 4, plus 4. So this is under minus 4. So when it comes here, we are going to have plus 4 is equal to 0. So here we have y minus 4x. 4 plus 4, we are going to have 8 is equal to 0. So that means the equation of the tangent is equal to y minus 4x plus 8 is equal to 0. So the second one we have to find equation to the normal. It's two questions from the statement itself. Find equation of the tangent and to the normal. So we have gotten for the tangent. So let's find for the normal now. So just apply the same formulas. So please don't forget what we get for the gradient is 4. So going to the formula, that is y minus y1 equal to minus 1 over dy dx of x minus x1. So don't forget our x1 still remain as 1, our y1 still remain as minus 4, and our dy dx, we have it to be 4. So let's just substitute the three datas that we have there. So here we have y minus, my y1 is minus 4, that is minus 4, minus 1 over, so what we have for dy dx is 4, we have 4, x minus x1 is 1. You can see the only difference is for the gradient, to the tangent is dy dx, and to that of the normal is minus 1 over dy dx. Please do not get perplexed. That's the only difference between the first one and the second one. So here I can have this one to be minus minus, of course we are going to have plus, that is a y plus 4 is equal to minus 1 over 4 of x minus 1. So now let's cross multiply so that 4 can multiply what we have. That means that we have 4 bracket of y plus 4 is equal to minus 1 bracket of x minus 1. I hope you get it right. Yeah, good. So let's open the bracket. 4 times y, and we have 4y. 4 times 4, we are going to have 16. Minus 1 times x, we are going to have minus x. Minus times minus, we are going to have plus 1. So now, let's collect the like terms now. So we have 4y. So this is minus x. When it comes here, we are going to have plus x plus 16. So this is plus 1 also. When it comes here, it's going to become what? Yeah, minus 1 is equal to 0. So that means that we have 4y plus x. 16 minus 1, we are going to have 15 is equal to 0. So that's equation number to the what? To the curve. So let me just add this one to it so that it will be of its value. Or in case if you miss that one, second derivative text using to determine the maximum and minimum point. Second derivative text. So how are we going to use the second derivative text to determine the maximum and minimum point? We have what we call critical values.